Okay, so we've learned previously that we know how to differentiate sin x and cos x. But now in this video, we're going to be looking at how to differentiate other trig terms such as tan, sec, cot, and cosec. So on this page, you can see the derivative of each one respectively. This is actually given to you in the formula booklet, but it's best to try and memorize this because you don't want to be referring back to the formula booklet every single time. And also in some questions, it might pop up, so you want to basically answer them as quick as possible. So first of all, how do we get each term? So you need to know how to get the derivative of each one. So let's start off with tan x. So let's say y is tan x. The way I differentiate this is I'm going to change tan x into sin x over cos x, like so. The reason why I just did this is because now I can use the quotient rule to differentiate it, right? Because we know the derivatives of sin and cos, and we also know the quotient rule is used when we have a fraction. So we know that u has to be the numerator sin x, and v has to be the denominator cos x. So therefore u prime is just cos x, and v prime is negative sin x. And using the quotient rule, dy by dx, it's going to be v times u prime, so these two multiplied first, which gives us cos squared x, minus u times v prime, so these two multiplied together. There's a minus here, right? So this turns to positive sine squared x, and that's all over v squared, so it's going to be cos squared x, like so. Now we know the identity cos squared plus sine squared is 1, so that means it's going to be 1 over cos squared x. And 1 over cos is sec, so this is going to give us sec squared x like this. So this is where the derivative of tan x comes, or is sec squared. That's how you prove it. The other three as well is the same method. You change it in terms of their sine and cos configurations and do the same thing. You apply the quotient rule and you should get the derivatives. Maybe as an exercise, you can try the other three and hopefully you'll get the right derivatives. Right, so moving on. As we said, we know how to differentiate sin x. It's just simply cos x, right? However, if I now write it as y is equal to sine 2x, like this, well, when we differentiate this, what we have to do now, because the angle is no longer just x, we should always remember we should differentiate this angle first, giving us 2, and you bring it to the front, and then you differentiate the sine, which gives us cos. And the angle remains as 2x like this. Okay? So whenever there's an angle inside the bracket, we should always differentiate that first, bring it outside, and then you differentiate the trig term, leaving the same angle inside the trig term. So the general formula they will give you is y is equal to, let's use cos. So if y is equal to cos f of x, where f of x is any function, it could be 2x, it could just be x, it can be anything. The derivative of that, it will be, in this case, negative, because cos to sine is negative. F prime of x, so we differentiate the angle, and then sine f of x like this. Okay, so it's basically what we just showed for sine, but just doing for cos as well. And this rule applies to all the other trig terms, so all the tan, sec, cot, cosec trig terms. As you can see here, they've written it in terms of k. So in this case, you could think of k as the function, okay? But sometimes the function can be more than just a number. It could be like 4x squared plus 1. So this rule applies for that as well. You have to differentiate that and you bring it to the front. Right, let's look at some more examples. So if I had y is equal to 2 cot 4x like this, okay? So it's a trig term. So first things first, dy by dx. We have the 2 in front, so we leave that 2, and we multiply the derivative of this function, which is 4. And then we differentiate cot. So if we go back up here, the derivative of cot is negative cosec. So don't forget the negative sign. So I'll put a negative in front. Cosec squared, and the angle remains as 4x. So this would be minus 8 cosec squared 4x like so. So as long as you follow those simple rules, then you should be able to differentiate all these different terms. And with this, we can also use the rules we learned previously, the product rule, chain rule, and the quotient rule. An example of this is, say, if I want to differentiate sine squared 4x, like so. I can rewrite this as sine 4x all raised to the power of 2, like this. This way I can identify, well, because there's a power, we should use the chain rule. And we learned in the previous video about chain rule that it's just a 3-step process, right? The power comes to the front, so 2. We now differentiate inside the bracket, so differentiating sine 4x. Well, we have the 4, so 4 comes out as well, and the derivative of sine is cos 4x. And then we rewrite the whole thing, bracket minusing 1 to the power. So it's going to be sine 4x minus 1, 2 minus 1 is just 1. So this will leave us with 8 cos 4x sine 4x like so. Okay, so even though it's a bit more tricky terms and we're now incorporating trig terms, the chain rule still applies as we learned it before. Let's take a look at using the product rule. So let's say we have an equation y is equal to e to the 4x sec 3x. Okay, we know the product rule is used when we have two functions multiplied together. So we have e to the 4x as one function, sec 3x as another function. They're multiplied, so we should use the product rule. So we have to set our u and v. Remember, for the product rule, u and v can be anything, right? It's the quotient rule where we have to be very specific of what our u and v's are. So in this case, it doesn't really matter. So e to the 4x as u, sec 3x as v. So therefore, u prime is going to be 4e to the 4x. V prime is going to be 3. And then if we go back here, sec turns to sec tan. So it's going to be 3 times sec. The angle still remains as 3x, tan, and 3x as well. Now we can just apply the product rule. So dy by dx is equal to, once again, the order doesn't matter. So these two multiplied first. So we get 3e to the 4x sec 3x tan 3x plus these two multiply together, so 4e to the 4x sec 3x like this. So the questions are getting a bit longer and more complicated, but I just follow the simple rules for the product rule and I still get the answer, right? So when you guys are trying to solve these questions as well, just make sure you clearly state what your u and v's are, clearly differentiate each one separately, and you should get the answer all the time. Okay, let's look at one more example using the quotient rule. So let's say we have y is equal to, I'm going to go for now cos squared 3x over ln x squared. Is one function divided by the other, so therefore we use the quotient rule. Remember, for the quotient rule, the u and v's have to be very specific. So the u has to be the numerator, which I'm going to rewrite as cos 3x all squared. And v I'm going to write as the denominator, which is ln x squared, like this. Now, once we've identified that, we have to differentiate it. So raise to the power of 2, use the chain rule. The 2 comes down, differentiate the angle is 3, and then we sine 3x, and then we rewrite the whole thing, cos 3x minus 1 to the power. So 2 minus 1 is 1, so it's just cos 3x on its own. V prime, we know how to differentiate ln terms. It's always a fraction, right? Where the angle or the inside the bracket comes to the denominator x squared. We now differentiate that x squared to get 2x, which will simplify to 2 over x. Right, now it's just a matter of using the quotient rule formula. Remember, for the quotient rule, it's very specific, so it has to be v times u prime first. So this is 6 sine 3x cos 3x ln x squared. Has to be minus u times v prime, so that's going to be 2 cos squared 3x all over x, and that's all going to be over v squared, so it's going to be ln x squared all squared like this. So I just followed all the different rules to answer all these different questions. As long as you guys have a clear step-by-step process for each different type of rule, and if we're differentiating trig terms or e terms or ln terms, then you should be able to answer any question that the exam paper will give you.